The goal of this research is to tackle one of the fundamental limitations of virtual reality systems today. How do you move around in the virtual environment? At some point, the user might want to explore a large environment, like an outdoor city. And if they're standing in a physical room, they're gonna hit a wall. So how do you overcome this fundamental limitation where you want to move over really large-scale virtual spaces, but your body is physically situated in a room of limited size?
The way we sort of solve this is by applying certain perceptual tricks, which we call redirected walking.
Basically just trying to make people walk in sort of the curved path. So it looks to you like you're walking on the straight line, but behind the scenes we're manipulating the virtual space to rotate around you so that you actually end up going in circles.
Redirection works because the human vestibular system, your sense of balance, gets completely dominated by your visual system. You will essentially believe what you see over what you feel.
The way it works is we have a map of the environment which you can use on a tablet. You can actually identify the areas that you want to visit, so you can essentially create this tour of environment. And then you put on the helmet, the head-mounted display, and you are immersed in this virtual environment. So now you can explore it from the first-person perspective.
It doesn't matter what your tracking space exactly is effectively. You put on your head-mounted display and start walking around and marking points sort of to determine the boundaries of your tracking area. And our software takes those, the information that you've given and tries to fit the largest rectangle possible to fit in your tracking space. The neat thing about this whole setup is that it's designed to be flexible to account for any type of virtual environment and of course any type of tracking area setup. So it's sort of like a plug-and-play situation where you just throw in the environment that Unity has given you and throw in our software with it, and they all work.
The end goal is to try to make the virtual reality experience more organic, feel more realistic. We don't want people to actually understand that they're being redirected. We want them to experience the narrative as a continuous sort of flow of the story.
There are applications in entertainment, in physical rehabilitation, in training and education. This research can improve the experience of VR and ultimately make it more effective.